Today we're going to be talking about another transformation for the sine and cosine graph. And that is, specifically, we're going to be looking at a change in the period. So as you may have recalled from last week, the period is the length of time that it takes to get through one entire cycle. Right? So for the sine, it takes 2 pi to get all the way back to where it starts. For the cosine, it also takes 2 pi to go from the high and get all the way back to where it starts. So the standard period for both the sine and the cosine is 2 pi. That's the standard period. But when you introduce a coefficient in front of x, here, right, notice the b, then the period gets changed to 2 pi divided by b. Okay, so the period, the distance along the x-axis the graph takes to complete one cycle. And for us, the period is always going to be equal to 2 pi divided by b. And again, b is the coefficient for x. So b also is the frequency. The frequency represents the number of cycles that can be completed within a standard period. So remember, our standard period was 2 pi. When b is a large number, okay, so we're here. When b is greater than 1, okay, then there are going to be less waves, okay? And so, okay, it looks like my pictures are reversed. So let's do this. Let's change this into when b is less than 1. Okay, when b is less than 1. Okay, when b is less than 1, there are going to be less waves. Okay, and so the period or the length of the wave is going to be longer. You see how this wavelength right here is much, much longer than this wavelength right here. Okay. And then when b is greater than 1, okay, so let's switch those signs. When b is greater than 1, there are going to be more waves, right? Because we have more frequency. In other words, more waves are going to show up. And if you want to have more waves in the same amount of space, the period or the length of the wave is going to have to be shorter. Okay. So again, make sure you switch this. This one needs to be b is greater than 1, and this one needs to be b is less than 1. Okay? So we're going to be changing the wavelength. So how would you graph something that had a period change? Well, the first thing you want to do is you want to calculate the period, right? So that's where we use this little equation right here, 2 pi divided by b. That's going to be the period, okay? And then we want to use a scale, right? Our scale is going to be either using the 0, max, 0, min, 0 for the sine, or our max 0, min 0, max for the cosine. So remember we talked about those 5 number summaries? That's what we're going to be using for our scale. So let's take a look at the first example. Determine the period of y equals sine 1/2 x and then graph the function for 2 periods. So in this case, we know that b is equal to 1/2. So that means that we're only going to be able to graph half a sine wave, right? That's our frequency. And then to find the period, we're going to do 2 pi divided by 1/2 which is 4 pi. So there's our period right there, 4 pi. So let's mark our graph. There's pi right there. There's 2 pi. There's 3 pi. And there's 4 pi. And I'll make my 1 here and my negative 1 here. Okay, so the period is 4 pi. To determine the scale, divide this by 4, and that's pi. That means that every pi you're going to mark one of the critical points, right? Remember what our critical points were? They were up here. 0, max 0, min 0. So that's going to happen for the sign every pi. So 0, 0, max, 0, min, 0. Right? There's my 5 critical points, and they were every pi. So now I can connect them together, and that's my graph. Okay? So that's sine equals 1/2 x. In other words, in a standard period of 2 pi, right? There's the standard period right there. You see that instead of going through a hill and a valley, I only made it through the hill. So I only made it through half of a period. All right, let's look at the next example. Determine the period of y equals cosine 2x, then graph the function for 2 periods. So again, I'm looking right here at the b value. The b value is equal to 2. That's the frequency that tells me I'm going to have 2 and then the period is going to be equal to 2 pi over 2. In other words, the period's going to be pi. Okay, so let's get ready to make our graph. There's pi right there. And there's 2 pi. And then 1 and negative 1. Okay, so I need to graph a whole cosine from here to here, right? So what does the cosine look like? It looks like max, 0, min, 0, max. Right? There's one cosine. And we can do that again. Max, 0, min, 0, max. And what we notice is that we have completed 2 cosines, right? 2 cosines in a standard period of 2 pi. So the frequency matches and the period matches, right? We said the period would be pi. Okay. Next example. This one involves an amplitude and a vertical shift and a period change. Okay, so let's take a look at this next one. First thing you'll notice on this one is this +1. Right? So we can bump everything up 1. The second thing I'm going to notice is the change in amplitude, right? The amplitude is equal to 2. The vertical shift was equal to 1, right? So that means that I'm going to go up 2 spaces from the vertical midline and down 2 spaces from the midline. And I know in between those 2 lines is where my sine graph is going to live. The last thing I want to look at is the b value right here, right? The frequency. The frequency is equal to 3. I should be able to graph 3 sines. But the period is going to be equal to 2 pi divided by 3. And that is going to be 4 boxes. Okay, so here's my 4 boxes. 4 boxes, 4 boxes. Every 4 boxes I should be able to fit in one sine graph. What does a sine look like? Remember, it goes a hill and a valley. Well, there's one sine right there. Okay, perfect, one sine. Let's do it again. A hill and a valley. Right, there's 2 sines. A hill and a valley. There's 3 sines. So we were able to get 1, 2, 3 sines in, right? That was our frequency, 3. each having a period of 2 pi over 3. All right, let's try another example. Determine the amplitude and period of y equals -4 cosine pi x, and then graph the function for 2 periods. This one has a little less going on with it. What we want to notice is that we have an amplitude of 4. We also know it's going to be upside down because there's a negative in front. And then the leading coefficient is pi. Okay. So this is a tricky one because we actually have to figure out what pi is going to look like. Okay. How do you have a frequency equal to pi? This is one of those things where we kind of think of pi as being close to 3. Okay. So about 3. And that means that the period, which is 2 pi over pi, the pi's are going to cancel and the period is going to be equal to 2. Okay, now that's a kind of a hard thing to think about graphing. How can you have a period that's equal to 2? Okay, because it's 2 radians. You have to think about how many radians would be equal to 2. And the best way to do that is just to estimate it on your calculator. If you take your calculator and calculate what is 2 pi divided by 3, you'll find that it's about 2.09. And what that means is that 2 pi over 3 is going to be our period. We're just estimating here. Okay? So, first couple of things we're going to do. Let's start with the amplitude. Okay? It's going to go up to 4 and down to -4. And we didn't have a midline change, so it's not going up and down. So we're still just using the x-axis. Right here, we're still just using the x-axis. And then the next thing we want to do is put in the period changes, right? So every 4 boxes, we're going to be able to draw a cosine. Okay, let's draw our cosine now. Remember, the cosine's going to start at the top. Halfway through, it's going to be at the bottom. And then by the time we get done with the period, it's going to be back at the top. So ready to draw our cosine. Here we go. All right, there's 1 cosine. Let's do it again. There's 2 cosines. Right, 1, 2 cosines. Let's do it again. There's 3 cosines. Okay, and we said we thought the frequency would be about 3 cosines. And sure enough, on our graph, there's pi right there, and there's 2 pi right there. So we did, in fact, get about 3 cosines in. Now, we're just estimating, right, because 2.09 is not exactly equal to 2. But it turns out that when you have a period of 2, it's about the same as 2 pi over 3. All right, let's look at the very last example, and then we can be done here. Determine the amplitude, period, and vertical shift for the function. First thing I'm going to do is look at vertical shift by drawing a dotted line right through the middle of my waves and my troughs. It turns out that the vertical shift here is nothing. So the d value of our equation is going to be 0. We don't have to worry about that one at all. All right, let's look at the amplitude. If you put in a line at the maximum value and at the lowest value, it looks like the amplitude here is about 1.5. So we can say that the amplitude is 1.5. Let's take a look at the period change. How long did it take us to get through one whole cycle of the sine? Well, look at that. So it looks like it took us to get all the way to 4 pi. So we know that the period is equal to 4 pi. Well, remember, the period doesn't get us to the b value, right? The b value is the frequency. So there's 2 ways to get to this. One of the ways to do it is to set this equal to 2 pi over b and solve for b. So